Okay, welcome back. We're working on more trigonometric identities. These are the things I think you should memorize, that you should know. Things are different than when I went to school. We were never allowed note cards in any math class that I can remember taking, even very advanced ones. You simply were expected to memorize it. It's very hard to say what your instructor will do. I recommend, I'm going to put up what I consider the minimum that you memorize, okay? And the first one is the most important and obvious, hopefully. Sine squared x plus cosine squared x is equal to 1. Oops, that's a, yeah, okay, so I'm going to clean that up a little. From this, we kind of figured out with our other definitions of functions that tangent squared x plus 1 was secant squared x, and that cotangent squared x plus 1 was cosecant squared x. And maybe let's take a look at this one more time to make sure that you understand why these things are true and how to prove these things, because we're going to start getting more complicated today. So we start with cotangent squared x. Cotangent squared x is the same as is 1 over tangent squared x. This is the same as cosine squared x over sine squared x. So cotangent squared plus 1 is cosine squared x over sine squared x plus 1. I need a common denominator because 1 is really 1 over 1. I'm going to use sine squared. So now we have sine squared on the bottom. We can add across the top. Cosine squared x plus sine squared x over sine squared x. And of course, cosine squared plus sine squared is equal to 1. So this is equal to 1 over sine squared x. This is 1 over sine x squared. This is cosecant squared x. And I just threw this extra in there to remind you of what the notation meant. These show up in calculus. In particular, this one shows up in calculus very frequently. There are some other identities that I definitely recommend that you memorize. I did back in the day, and our instructor made us, and we use these in calculus a great deal. Okay. And I've shown these, I put these up before. Cosine x plus y is equal to cosine x times cosine y minus sine x sine y. And here's the thing to remember about it. When you add inside here, you get the subtraction here. It's just one of those things, you'll get used to it. Cosine x minus y is the same, except we change the minus to a plus. This is cosine x cosine y plus sine x sine y. Sine x plus y is equal to sine x cosine y plus sine y cosine x, and sine x minus y is equal to sine x cosine y minus sine y cosine x. These are very useful. You're going to be needing these. You're going to be using these so much, hopefully you will just memorize them by how much you use them. If you don't, write these down every day until they're in your memory. One of the obvious consequences of these are, and we did this last time, but these are important. Sine 2x. Well, this is the same as sine x plus x. So we're going to use this formula, only the y is just going to be an x. So everywhere there's a y, there's an x, so this is going to be equal to sine x times cosine x instead of cosine y, plus sine x, which is replaced for the y, and cosine x. This is 2 sine x cosine x. This shows up quite a bit. As a matter of fact, enough that I'll put it on the list of what I would strongly recommend that you memorize. So sine 2x is 2 sine x cosine x. Similarly, another very often seen equality is this. What about cosine 2x? Now this is the same as cosine x plus x, so we're going to follow this formula. And this is going to be cosine x times cosine x minus sine x times sine x. This is cosine squared x minus sine squared x. And this one shows up quite a bit, so I'll also put it up. Okay, so what's up on the board right now? I would say that this is the minimum identities that you should memorize. I strongly recommend that before the first test comes that you know these. Not only that, that you remember them and keep them in your memory whenever you go to calculus. And incidentally, those of you going on to calculus, don't make a mistake of taking this class and then waiting a year before calculus, because you'll forget a lot of it if you don't do it on a reasonable basis. So I recommend that you keep these in your memory and then get right in your calculus class and ace it. I think at this time I'm just going to start working problems that you're going to see soon on your test. And let's take a look. It says that sine x is 1/3, and it's in the first quadrant. So this is like a potential test question. We have sine x is equal to 1/3. 0 is less than or equal to x is less than or equal to pi over 2. This says first quadrant. All right, so if we look at that, this is over here. What other information does it give us? What is sine pi over 4 plus x? So they want to know, what is sine pi over 4 plus x? Okay, so the first thing we're going to do is just go into the formula right away. Let's just use this and see what comes up. Then we're going to have a numerical value. So here's what we need to think about first. We're in the first quadrant. Sine of x is 1/3. So somewhere sine of x is somewhere over here. Basically, if sine of x stays in the first or the second quadrant, it'll still be positive. This is 45 degrees. Is this enough to knock it over past 180? Well, first let's just see what the numerical value comes out, and then we'll take a look and see if we can think about what it means. This then is sine pi over 4 times cosine x plus sine x times cosine pi over 4. And we'll be back in a minute.